This is my Module 1 Mastery assignment. The first topic I chose was asymptotes and limits at infinity. For Part B, I first defined asymptote, which is a line that a curve approaches as it heads towards infinity. Next is the end behavior of a function. This is the behavior of a graph as the x values approach infinity or negative infinity. Next, I described the end behavior of exponential functions, which is where x values go to negative infinity while y go to 0. Then we did logarithmic functions. X goes to infinity from the right while y approaches negative infinity. Lastly, I defined limit, the value that a function approaches as the input approaches some value. The example I chose for Part C is limit as x approaches infinity. The numerator is 2x minus 1 multiplied by 3 minus x, and the denominator is x minus 1 multiplied by x plus 3. To solve this limit, you first need to FOIL the numerator and the denominator. Then you can combine like terms until it can't be simplified any further. Then you divide all the terms by the highest denominator power and then simplify again. Next, you can solve both the top and bottom limit by separating into terms, then finding the limit of each individual term and adding them. We get negative 2 as the numerator and 1 as the denominator, which simplifies to negative 2. This means the limit is equal to negative 2. The second topic I chose was direct substitution property of limits. For the important points, I put limit x approaches a, f of x equals f of a. Then I did, you can always use direct substitution to find the limit of any polynomial function. However, not all limits can be evaluated using direct substitution. The example problem I used was limit as x approaches 2, and the numerator is x squared minus 4, and the denominator is x minus 2. To solve this limit, you must first expand x squared minus 4 into two binomials. Since x squared minus 4 is a perfect square, you know that the two new terms are going to have one positive 2 and one negative 2. Once you factor, you can see that the term x minus 2 in the numerator cancels out with the term x minus 2 in the denominator. Now all you have to do is plug 2 in for x and you can get the limit equals 4.